Hey guys, welcome to MooMooMath. Today we're going to learn how to graph logarithmic functions. We're going to mainly focus without a calculator. So let's get started. The first thing we want to do is look at the relationship between the exponential functions and the parent and the associated logarithmic functions. Okay, so we're going to start off with the exponential function y equals 2 to the x. Well, let's go ahead and make a table of values. So when I plug in -2, 2 to the -2nd is going to give me 1/4. 2 to the -1st is going to give me 1/2. 2 to the 0 gives me 1. 2 to the 1st gives me 2, and 2 to the 2nd gives me 4. So I've got a table of values. Now we can go ahead and graph those. So 2, 4, 1, 2, 0, 1, -1, half, and -2, 1/4. So I have this exponential function that looks like this. And we know part of the function is we have an asymptote at 0. So let's make a little hash mark along here to show an asymptote. And there's our graph. Now, our domain, as you can see, goes left to right forever. So in interval notation, our domain is all real numbers, -infinity to +infinity. And our range, well, our range is from the x-axis up, so it's from 0 to infinity, and it does not include the x-axis because that is an asymptote. Now, we know that these two functions are inverses of each other. So if I were to switch my x and y values and make this x is equal to 2 to the y, and then solve this for y, I would get log base 2 of x is equal to y. Well, that's the inverse function we're looking at. So we know with inverses, we can actually just switch our ordered pairs. So I could actually take this exponential function, switch my x's and my y's, and come up with a table of values. And that's actually what we're going to do. But before we do that, let's take a second and think about what these inputs, what happens with these inputs right here, these first three. If I switch these two values, okay, my x's and my y's, I'm just going to make a little chart over here. I'm going to get 1/4 common, or -2 as 1 point. I'm going to get 1/2 -1. I'm going to get 1, 0. I'm going to get 2, 1. And I'm going to get 4, 2. Now we know that our domain is going to be the range of the exponential function. So my domain is from 0 to infinity, and my range is the inverse's domain, so it's -infinity to positive. It's all reals. Okay, so let me erase this for a second so we can see our chart a little bit better. Okay, so let's think about this. When we plug in the value -2 into the logarithmic function, look what happens. Our domain is not evaluated on -2. So this was DNE. It doesn't exist. We can't take the log of that negative number. Same thing with 1. It doesn't exist. It's a negative, and we know our domain is not negative. Now, how about 0? Does this domain include 0? No, it doesn't. So that, again, doesn't exist. Well, let's think about our asymptote for a second. Our asymptote on exponential function is y equals 0. It's the horizontal line at 0, which is the x-axis. So what do you think the asymptote for the logarithmic function is going to be? Well, remember, we just switch our x and our y. So that means x equals 0 is our asymptote. So I'm going to make these little hash marks all the way down my y-axis. Okay, now I can get a couple values right here. So as you can see, we have these two values we can plug in. We can plug in 1, 0, and we can plug in 2, 1, because you can evaluate log base 2 of 2 is 1. And we also have this other one right here. So let's use the 0.42, so we have 3 good points to graph. So here's 1, 0, and here's 2, 1, and here's 4, 2. There we go. Now we could get another one. The next kind of nice number for this function is 8, and that would be 8, 3, because 3 cubed is 8. So we could actually even graph that. Let's graph that one too. And we know that our asymptote, our graph approaches the asymptote, and it will go through these points. There we go. That's kind of the best I can do with this setup. But there's my graph. So as you can see, these two graphs are inverses of each other. So remember what we talked about inverses. We talked about the fact that if you reflect over this y equals x line, you can see that graph. So I'm going to go over here for a second, and I'm going to just, wait, let's see if I can do this. I'm going to copy this, and I'm just going to paste it back on the page. And, oops, it didn't pick it up. Let's see if I can pick it up. I can't. Oh, well. I'll just pick the original one up. There we go. Oh, there it is. It's up here. Boom. We'll put it back down there. Okay, so there's our graph. Okay, so you can see it is a mirror image or a reflection over that y equals x line. Isn't that pretty cool? So you can see that reflection. And now let's look at another one here. Okay, let's look at one that's the same function, but we've got some shifts going on. Okay, think about this. We have x minus 3, and we know from the past all of our h's and k's in a horizontal and vertical shifts. So for a logarithm, we've got y equals log, and I'll call this base b, of x minus h, where h is our horizontal shift, and plus k, which is our vertical shift. Okay, so we have a base of 2, so we've got to think about that parent function, the original function that's exponential, as y equals x to the 2 to the x. Okay, that's our related exponential function. And now we have the log, which is its inverse, so we got a base b, and then we have a horizontal shift of 3 and a vertical shift of 0 in this case. So what we're going to do is we can actually generate some points that we want in the graph. So we've already generated a few for our exponential function, so we're going to transfer those over here. We're going to switch, and then we're going to apply these rules. So where do we think our asymptote is this time? Well, what you've got to do is you got to think about the horizontal shift. What do you think our domain's going to be? Well, that's going to depend on that shift, isn't it? Now the range is pretty easy. The range, and we can go back, look at these. Our range is going to be all real numbers, because you can see this does increase it slowly. It increases slowly, but it does increase. Now, you can see in the negative direction, negative infinity, it does go pretty quickly. But the positive direction is going up. It's just going up very slowly. So you can see that. And then our x-intercept. Sometimes we're going to have a y-intercept depending on where our asymptote is, but we would definitely will have an x-intercept, because we know that the range is from negative infinity to positive. It's all real numbers. Okay, so let's see if we can figure out where this asymptote is. Well, where does the graph start? What makes this portion of the logarithm function 0? Well, we know it's 3. So that is where our asymptote is going to be, and it's going to be x. Whoops, that's not a very good x. Let's erase that. We know it's a vertical asymptote for a logarithm, so we're going to put x is equal to 3. So let's go down and get a graph and plot that here. Boom, there's our asymptote. Now that means our domain is either on the left or the right. Well, this one's not reflected, so it is going to stay on the right side of it. So we're going to go from from 3 to infinity. So our graph is going to be on the right side over here. Now, our x-intercept, that's what we're going to get once we start shifting. Okay, what you need to be comfortable with is getting 3 points from the exponential graph, switching the coordinates, and then applying any transformations. So we're actually going to make 3 tables here. Okay, let's start with, let's start first with just y equals 2 to the x. Let's just get some easy ones. Let's do -1, 0, 1. Let's do 4 of them. Let's get 2. Okay, so -1 gives us a half, 0 gives us 1, 1 gives us 2, and 2 gives us 4. Now, for our related parent function in logs, what we're going to do is we're going to generate log base 2 of x, just the inverse, and that's going to give us a half, -1, 1, 0, 2, 1, and 4, 2. Okay, so we just got that from switching the x and the y coordinates because we know those are inverses. Now let's apply any transformations. When this problem, all we've got is a horizontal shift. So we're going to take our x coordinates and we're going to add 3 to it. So it's a shift to the right 3. The y coordinate is not changing at all. So there's no rule for the y because there is no k value. So we're going to take each x value and add 3. So that's going to be 3.5. Okay, we're going to add 3 to 1. So that's 4. Add 3 to 2, and that's 5. And add 3 to 4, which gives us 7. And then the y values stay at -1, 0, 1, and 2. So now let's plot these points. This is supposed to be 3.5 if you can't read it. Okay, so 3.5, -1, and then 4, 0. So our x-intercept is 4, and then 5, 1, and then 7, 2. There we go. And that gives us a graph of this logarithmic function. Sorry, it's really hard to write on this board as it approaches the asymptote. Okay? And we just said our x-intercept is 4, 0, because intercepts are ordered pairs, right? Okay, so let's try another one. This one's different because we are changing the k value. Okay, so what I'm going to do, rather than generate that whole list again, let's go back and, you know what, I'm just going to snip this right here because we're just going to use this graph. Let's pop it on here. Hopefully you can see it on yours. Whoops, that's not good. Let's take that little line off. Okay, there's our graph, our log graph before we do a shift. Okay, what we're going to do now is our little table where we're going to change our slides. So x has no change, but the y, we're adding 3 because we've got a k value of 3. So we're going to get a half, 1, 2, and 4. Then we're going to add 3 to each of these y values. So that's going to give us a 2. That's going to give us a 3. That's going to give us a 4. And that's going to give us a 5. So let's plot those. Okay. So where does our graph start? Our graph starts, well, our asymptote. Our asymptote is going to be whatever makes this 0, what we're taking the log of. Well, what we're taking the log of, what makes that 0? It's just 0. So here is, let's throw in our asymptote. Okay, it's right here. Pop that on there. There's our asymptote. And now let's plot those 4 points. A half, 2, 1, 3, 2, 4, and 4, 5. So you can see really all we did was shift the parent graph up 3 units. Okay, so our domain did not get shifted from the parent log function, this function right here. The range still remains all real numbers, negative infinity to positive infinity. But what is the x-intercept? Well, to find the x-intercept, we're going to need to set this log equal to 0. To find the x-intercept, you plug in y is 0. To find the y-intercept, you plug in x is 0. So let's plug that in. Okay, so now we need to solve this for x. So we're going to get negative 3 is equal to log base 2 of x. Okay, now we need to solve this for x. So that means we're going to have to rewrite. We're going to put it in exponential form. So 2 to the negative third is equal to x. So we know 2 to the negative third is 1/8. So there we go. There is our x-intercept. So we're going to get 1/8, comma, 0. And that's how you find the x-intercepts. Now, if there's one that you couldn't solve, you can always leave it in log form if you need to. Okay, so let's try this one. Now, what's different about this one is it has a different base function. We're going to have to go back and generate a couple points from an exponential function with a base of 3. So let's go back and generate these. So let's see. We know that the domain is all reals. So let's just create -1, 0, 1, and 2. That'll give us 4 good points. That's going to give us 1/3. That's going to give us 1. 3 to the first is 3. And 3 squared is 9. So that means the related log function, y equals log base 3 of x, is going to be equal to 1/3, -1, 1, 0, 3, 1, and 9, 2. Okay, now let's apply any transformations. Well, let's see. What have we done? We are taking x and we are subtracting 1. We have a left shift, but y stays the same. So let's take this 1/3 and subtract 1/3 minus 1 is -2/3. There's no change in the y coordinate. 1 minus 1 is 0. 0, so it goes through the origin. 3 minus 1 is 2. The y coordinate doesn't change. And 9 minus 1 is 8. And the y coordinate doesn't change. So now, guess what? I have a y-intercept this time because, dun, 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 I have a shift in my asymptote. So let's draw that asymptote. Where is the asymptote going to be? Well, we have to look, where does this function give us 0? Or where does x plus 1 equal 0? And that's at -1. So that means here's my asymptote. Let's plot these. I'm at -2/3, -1. So there's my first point. 0, 0 is part of the graph. 2, 1. And 8, 2. Wow, there's my graph. Okay, so it's going to go up and over. Now this one has both an x-intercept and a y-intercept. So the x-intercept this time is the origin. Well, it's also the y-intercept because it's crossing at the origin. Okay, our asymptote is a vertical line at where that is 0. So just take x plus 1 and set it equal to 0. That's going to give us x is -1. That's the easiest way to get the asymptote if you're ever confused. Okay, the domain is this time from -1 to infinity, and the range, of course, goes up and down forever, slowly up, but it does go up and down forever. Okay, so that's how you graph these. And that's kind of how you get the gist of these. Okay, let's do one more with a different parent function. Let's start with a base of 6. So y equals 6 to the x. Okay, let's generate these points. -1 will give us a 6th. 0 gives us 1. 1 gives us 6. And 2 gives us 36. So that's probably not going to fit on the graph. That's why we kind of stick to 3 points, because sometimes they don't fit. Whoops. Now let's do the log. So y equals log base 6 of x. Okay, so we're going to get a 6th, -1, 1, 0, 6, 1, and we can't fit it on there, but 36, 2. Okay, now let's apply the transformations or the shifts. Okay, so this time we have what with the x-coordinate, we add 1, but with the y-coordinate, we add 2. So these are the h's and the k's you're adding. So let's add 1 to all the x-coordinates, add a 6, and then add 2 to the y-coordinate, add a 6th, or add 1, sorry. That's going to give us 2, and that's going to give us 2. And then add 6 plus 1 is 7, and 1 plus 2 is 3. And then that would be 37 and 4. Okay, so now let's plot these. Okay, first thing we need to do is throw in our asymptote. Our asymptote is where this is 0. So let's see, our asymptote is x equals +1. So let me go back and grab that line one more time. Let's throw in our asymptote. There we go. Okay, now our domain. This time it starts at 1, because that's where our asymptote is, and goes to infinity. And the range is -infinity to infinity. And the x-intercept, well, let's look at our chart. Do we have one? Can we see it? We can't really see it from a chart. So 1 and a 6 is and 1. That's above the x-axis. 2, 2. 7 and 3. So there are 3 points that create the graph. That's your minimum. You need 3. Okay, whoops, this should come a little closer here. Now what we need to do is find this x-intercept. To find the x-intercept, we're going to set the function, or replace y with a 0. So let's solve for this one. This one's going to be a little trickier. Okay, so first thing we do is solve for x. So we'll have -2 is equal to log base 6 of x minus 1. Now we need to rewrite this to evaluate it. So we're going to get 6 to the -2nd is equal to x minus 1. And then that's going to give us 1/36 is equal to x minus 1. So then we add 1. So we're going to get 1 and 1/36 is equal to x. So there's our intercept. We write it as an ordered pair. So 1 and 1/36, 0. You could write it as 37/36, and that's fine. So it's really tiny right here. It's just slightly to the right of our asymptote. I like to write it as a mixed number just for graphing purposes. Okay, so there's what we've got now. This one's a little bit different because we have a negative. So let's see if we can't crank these out. This time we're going to have to generate the t-table for the exponential function y equals 4x. So -1 gives us a 4th. 0 gives us 1. 1 gives us 4, and 2 gives us 16. Okay, now our log function, that's going to be y equals log base 4 of x. So that's 1/4, -1. Whoops, that's a -1. 1, 0, 4, 1, and 16, 2. Okay, now let's apply our transformations. Now this one's a little bit different. Okay, what are we doing to the x-coordinate? we're subtracting 3. What are we doing to the y coordinate? Well, we have a negative y because the negative in front of the log, and then we're subtracting 5. So we're negating and subtracting. So let's take our x values and subtract 3. So that's going to give me 1/4 minus 3 is negative 2 and 3/4. That's a 3. 1 minus 3 is negative 2. 4 minus 3 is 1, and 16 minus 3 is 12. Now let's take the y coordinates. The first thing we're going to do is negate. So this negative 1 is going to be a positive 1, and positive 1 minus 5 is negative 4. 0, opposite of 0 is 0, minus 5 is negative 5. Opposite of 1 is negative 1. Negative 1 minus 5 is negative 6. And then negative 2 minus 5 is negative 7. So there are some ordered pairs. Now, what makes our asymptote, or where's our asymptote? So what makes this 0? Well, what makes that 0 is negative 3. So let's plot our graph, our asymptote at negative 3. Now, what's slightly different about this one is we have, let me get this, a negative right here. Okay, what does this negative do? Well, that is a reflection over the x-axis. So what I'm going to do is, I know instead of this coming from negative up, it's going to reflect it. It's going to come from positive direction and then down. Okay, so that's what's going to happen. So now, let's actually graph the points because it did get reflected. So I'm going to plot the point negative 2 3/4, negative 4. So here's a point. Negative 2, negative 5. Okay, and then 1, negative 6. There's this one. And then 12, I'm just going to kind of estimate this. 12, 7. Okay, so you can see, yeah, it's coming down, kind of stretching out quickly. It will stretch out more quickly the greater the base. Okay, notice this is getting stretched vertically very quickly, and that's because our base this time was 4 instead of 2. Okay, and there is our graph. Now our asymptote, we just said that. We said it's where what makes that 0, and that's where x is negative 3. So our domain goes from negative 3 to infinity, and our range, it does continue left to right forever, so all reals, and then our x-intercept. Okay, let's see if we can do this. So we're going to have 0 equals negative log base 4 of x plus 3 all minus 5. Okay, so we're going to add 5, so move the 5 over here. We have a negative log base 4 of x plus 3. Okay, now we need to divide by negative 1 to get the log by itself. So we're going to move this negative 1 over to the other side. So now we can rewrite. So 4 to the 5th is equal to x plus 3. So we take it out of log form to exponential form. And now let's evaluate. Let's see, what is 4 to the 5th? 4 to the 4th is 64. So let's see, 4 to the 5th. 4 to the 3rd is 64. 1,024. Okay, so that's 1,024 equals x plus 3. So that means x is equal to 1,000. Wait, that doesn't make sense. It's not crossing, it's crossing here. That's my x-intercept. What have I done? Oh, this is a negative. That's why. Okay, it's negative, which puts it in the denominator, and then we're going to subtract 3 from it. There we go. So it's going to be negative 2 and 1023 over 1024. Sorry, I dropped that negative. So it's right next to that asymptote. But that would be our x-intercept. So how do we write that? We write it as an ordered pair. Negative 2 and 1023 over 1024, comma 0. Bingo. There it is. And that's how you find that intercept. Okay? We've got a couple more that you can practice, but you can go ahead. Let's look at a natural log. Okay? So to do a natural log, what we've got to do is we've got to generate the basic equation for e. See if you remember these. E to the negative first is 0.37. E to the 0 is 1. And e to the first is 2.7. And e squared, do you remember? 7.4. Okay, now let's switch these. So 0.371, 1, 0, 2.71, and 7.42. Okay, then from here we're going to apply any transformations. Well, we don't have any because we're doing the parent graph, but we know that we could apply a horizontal, a vertical shift, and even a reflection. So let's plot these so you can see the parent graph. 0.37, 1, 1, 0. Oh, wait a second. That's a negative 1. That's why it wasn't coming out. 0.37, negative 1, 1, 0, 2.7, which is almost a 3, 1, and 7.4, 2. And there's our parent graph for a logarithm, natural log. Okay, so draw our asymptote down. And we know our asymptote is x equals 0. Our domain is from 0 to infinity. The range is negative infinity to positive infinity, all reals. And then our x-intercept. What's our x-intercept? That's right here. It's right here at 1. So it's 1, 0. Okay, now to apply any transformations, we're just going to do exactly what we've done. Okay, we're going to create our table. I'm going to come over here and snip it in a second. And we know we can just apply the transformation. So on this one, our transformation is x minus 4. So subtract 4 from all the x values. And then we're just going to multiply y by 3. So it's going to stretch up vertically. And I want to play around with that, see if you guys can do that. And you should be able to graph the rest of these. So go back, try this one. Y'all heard my dog. Right here. Here is this parent function before you, so if you need to, whoops, you can put this here and then apply these transformations. So I think you're ready to go. You can pick up your graphing sheet and see if you can go to town with the graphs. Good luck with graphing.